All right, thank you everyone. So today's talk is an introduction to Pulsar's database table abstractions. And why we wrote this is, oftentimes you find it more convenient to logically treat a continuous streaming data set as a table rather than a sequence of records that you process individually, right? It's more conceptually, the data tends to lead itself more as like a database representation. So in this talk, I'm going to discuss how Pulsar's new database table abstraction consumer actually allows you to do just that. So I always ask this question at every conference, and I just want to do it here. How many people here have heard of Apache Pulsar? Okay, thank you. That's a response I never get anywhere else, so thank you for getting that one. I just want to get that out of the way. So for those of you who don't know me, I'm a committer on the Apache Pulsar project with over 6 years of experience on it itself. I was one of the original members that helped get it from a sub-project to a top-level project. I helped deploy and maintain the first Pulsar cluster at Splunk that was capable of processing 10 petabytes a day of data per day for a cybersecurity ingestion platform. I'm also the author of Pulsar in Action, which we'll be giving away at the Stream Native table at 3 o'clock. I'll sign copies for those of you. I am left-handed, so you won't get a bad signature. Get the real signature on that. And before Pulsar, before I got Pulsar took over my life and consumed my every waking moment. I was one of the first members of the professional services teams at Hortonworks, which was a big data startup, where I focused on implementing business solutions for stream processing using Kafka, Spark, and NiFi for Fortune 500 companies around the world. So not only am I a coder, but I've actually put it in implementation and practices in the field for some of the larger companies. So without further ado, enough about me. As I mentioned before, when you're working with streaming data, you often need to continuously update and maintain the state of specific entities or keys as new data arrives, right? So you're processing things individually in a stateless manner, and you might want to have an application or need in your application to where you need to retain some internal state based on the previous data, right? So think of this thing, I'll give you some examples later, but rather than being stateless, you want to add some statefulness to your processing of the data itself. And one of the naive ways that you could do that, we'll talk about that, was to just like add a hashing data structure to your internal application. The key things comes in, you put it to that hash, and then you have that information. While that will work, there's lots of issues with that as far as it being, not persistent and things like that. So we decided to create a new table view. It's a consumer type for representing streaming data sets. You can think of them as sort of materialized views that do just that, retain some state over processing the data multiple times, right? So these data table abstractions allow you to consume data, again, as if it was a database table, do a quick lookup. And it's crucial for scenarios where you need to maintain the latest state for a set of entities, such as aggregations or maintaining counters, things like that. They can be used for lots of different things. Fast queries, analytics, reducing the need for processing data very quickly. And up until now, all the Pulsar consumers and readers were designed to fetch data one record at a time, process it while next. Think of it like as a result set in a database query, JDBC, something like that. Read the next record, read the next record. This puts a nice thin veneer on top of that. For those of you coming from the Kafka world, think of like K-tables. They did it, so we had to do it too. So it's a new consumer type. It comes in the API. It's available in Java, C++, Go, and .NET client libraries. So for Python fans out there, I apologize, it's still in the works, it's coming. But basically what you want to do is sort of, think of it as a change log stream for a keyed table, right? When these events come in, we sort of update that primary key table, and we update it with the newest value, and then when you go look at this table view abstraction, you know the latest value for that key that was processed, right? And this makes it much more convenient to do certain things, and we'll talk about how this is done internally. But really, it serves as an encapsulation access pattern that provides a continuously updated key value map view of a compacted topic data, and we'll talk about the implementation in the next slide. But this slide shows you how over time as data comes in, keys change, values mutate, and you have different values come in. So with a table view, Pulsar clients fetch all the message updates from a topic and construct a map interface on top with the latest values of each key. So the classic example of a topic that would benefit from this would be a stock ticker topic through which consumers can access the most up-to-date value of a stock ticker quote, and then just get that information and process it as needed from there. So this is exactly what I'm talking about here. This is another example of that. So you have stock tickers coming in. That's your obvious logical key. You have changing values and quotes over time. You're not interested in the quote from 2 seconds ago. You want the most recent one. So this is how you actually access that information logically. You would see just a subset of that data, and again, only the most recent value. So here we had like 5 different quotes. Deletes come in, they completely disappear. That's kind of another option as well. If you delete them from the topic, they go away. But how it's implemented under the covers is that we have, when you start a TableView consumer, under the covers there's a compacted topic created for that analysis for that same topic. Now for those of you not familiar with the compacted topic concept, basically it is a secondary standalone data structure that will scan the primary topic and then take the most recent data from that. So it moves a pointer forward and it takes the most recent value and persists only that data. So again, you take that large data set there on the left with all these entries with duplicate entries for like Netflix, and you reduce it down to its most recent value. It's used commonly in a lot of different streaming systems. It's actually what's used for Pulsar subscriptions. That's how we track subscriptions. We publish the acknowledgments back to a topic and then compact them, and so we move the cursor forward through topic compaction. So that's all that's there, and it runs in the background. A background reader runs in the background and reads directly from that compacted topic, not the whole one, so you don't have to scan a larger data set. You scan a much smaller data set, pruned data set for that particular use case, and then you can get access to that data from there. So how do you work with this a TableView system and how you implement it in the application as well? Just want to point out that, since it relies on a compacted topic, it's highly recommended that you configure your topic compaction policies on the namespace or topic to make sure that it happens as frequently as you want. It's triggered over time. So again, you're monitoring a very large topic with data. You say, this is my threshold for when I trigger a compaction. The defaults are rather large in the megabytes of size or number of messages. You might want to, if you want to aggressively update that more frequently, you can adjust your policies to do so to meet your SLA on that. Because there's an inevitable lag between the most recent record and the main topic and when the compaction occurs, so you have to account for that also in your topic, but it is a nice logical way to access this data. So this is, for those of you using Java, Java is my preferred language, so this is it. If you're using the Java client library, this is all that's required to create a table view. So you have an existing Pulsar client. You say, I want to consume from this particular table. This is the schema. Again, you have to specify the schema. There's right now, there's one configuration that you can change, which is the auto update partitions interval. That really just means if you're consuming from your source topic as a partition topic, how frequently you scan to determine if new partitions have been added, because that can change dynamically. So this is the interval in which you'll check for new partitions on your partition topic. Just something out there. It's not super interesting, and doesn't really impact the table view itself. And then obviously then you specify what your source topic is, and then you hit create, and that's it. So once you have your TableView client library in place and you have this running inside your code, the TableView API has several methods obviously, but these are the 3 that are actually get data back from. This is how I access the data. So I created this TableView, I have a compacted topic, data's running through the stock ticker quote, and I want to access this data in different ways. I won't go through all of them, but there are basically 3 different ways. Get by key, it's a point in time, look up this key, as you would imagine. What's the most recent value in the compacted topic for this value? You can do a quick lookup. You can do a for each, so it does this. You can pass in then a different action, a consumer of the topic schema type, and perform this action on every single one, one time. So just boom, process all the information, one time, do a scan on it, process it, you're done. And the third is the continuous one. So for each, you do a single scan of all the keys in that table, do your action that you pass in, whatever function you want to do in, and then registers a listener, like a message listener interface you're familiar with, and then the next time something changes or a new field is added to that compacted topic, perform that action again. So it's like a continuous query. So I want to calculate something on this first time, have a set of values, and then as the new values come in, as values change, you'll automatically update this information, and we'll see. I'm going to tempt the demo gods and do a live demo with one-armed. So this is really, really going out on a limb here on that. So again, this is just a summary of what I just said. You can use the get to join a table with an active stream consumer. So TableView to stream scenario, the for each is scan on the table once and perform an action on the contents exactly once, go through it. And then the for each and listen is sort of a continuous query and updates the contents periodically. So that's really, logically that's the cheat sheet of when to use each one of those 3 methods. So next, I came up with I wanted to walk you through a simple use case that has exactly two different data sources, or streaming data sources, stock quote data and stock trades. There's also a stock positions table in here as well, just to clarify that, but it doesn't move very much. Again, to implement a simple, very simplistic, rudimentary stock trading platform, but again, show you the value and how the power of this TableView abstraction can be used to do a lot of different calculations that you would natively do with like materialized views, or you put a Flink processing engine on it, or you do some sort of rising wave implementation on it to do logical SQL stuff. You can kind of do all these things with a TableView instead. So that's what I'm going to do. That's going to be the use case here. So the first one is obviously the stock quotes topic. It contains stock quotes coming in continuously. A very simple schema. The symbol is the key, and you just have a price. This is the time that somebody's advertising it to trade at, and that's really it. So obviously the ticker symbol allows us. It's a key topic, so we can use the table view and produce the most updated topic there. So again, continuously from oldest to latest, you can see we had two different Google quotes, and the most recent value should be shown there in the stock quote table view, representing that change in time. And just as from a characteristic of this data set, it's both high volume and high velocity, changing very quickly, moving very rapidly. So you might want to have a more aggressive compaction topic on that, but that's how you can convert that into a simple table view, and how that data changes over time is going to be changing quite a bit. The other one just sort of represents the stock trades topic, right? So we're getting in from our platform all the different trades that are executed inside. Let's say this is again built for somebody like you're a Charles Schwab or you're a Fidelity, and you want to track all the different trades executed on your particular client portfolios. You want to track it in real time. This particular data comes in as every time a trade's executed, you get the symbol that was executed, the number of shares that was included in that transaction, and then the executed price on that particular quote. And it comes in, and then that data comes in continuously. And inside the service itself, there's a single consumer called a stock stats calculator that grabs that latest value and then does an update in place, right? And that code's a part of my source code here. But as you can see, for example, Oracle was the latest one coming in. So, and what we're updating in the stock stats. So again, there's just a trade, Oracle, 100 shares of Oracle for $37.99. When we go in and we do a lookup in the stats and say, okay, what was the high, what was the low, and what was the total volume? So that's what's represented in that last column there on the far, on my left, your right. And then we updated that. So we added 100 to that value, 32,490. We put 37.99 was the low. And this is updating stats. So you continuously keep these statistics and publish them in a separate topic. And that's a single stream consumer. Nothing special about that. No table view. I'm just reading it, processing those messages, and putting it into a separate topic that I'm going to join on later. And so this is a way. So I'm doing this stuff, as we saw on the previous slide. The data from the stock trade topic is then used to feed a topic called the stats topics. And each record just contains the daily stats, as I mentioned before, high, low, along with the daily trading volume. And then you can apply a table view on top of that to see, your total different symbols. So like if you go to Yahoo Finance, you say, look up for a quote for Google, and you look in there, you can see the min, max, and the daily volume and all these things. And that would feed that type of data structure there. And that can be done from a table view, right? So I've done some pre-processing in the data set to feed it into another topic. Table view gives me that for free, basically. So I can do all that information, and as trades are executed, the values of the stock stats table changes. Again, that's on that, the stock stats calculator is continuously updating this table, and then my table view is being updated to reflect those changes as well. And then the stock positions table view is, let's say so everybody log into your account, we do a lookup, there is a stock positions stream just for me and just for you and just for every person who has an account. And it tracks when I execute a trade value, what comes in, and I change this information, right? So simulate, you just update the existing record by reading the previous value and updating the information in the stock trade details, right? So for instance, you can see in this account I had 100 shares of Google at one point in time, but these holdings increased by 200 later on as a result of a successful buy order coming into the stream, right? So similarly, the account position for Netflix dropped from 950 to 750 as a result of the sale. And so you can keep that information as well. Again, this information is just continuous. We're reading it right off of the stock position stream. So when the stock trades come in, I monitor it for just my account, and then I update any of those values and put it back into that topic as well. So now that I've covered the data sources for a stock trading platform, I want to focus on the or 3 different usage patterns for this table view consumer and in the context of how you look at it as a traditional database structure, right? So the first thing that you can do is join streams to a table view. So for data enrichment purposes, you can use the lookup capabilities on a table view to augment or enrich a streaming data set coming in. So such as joining the stock positions table that we talked about earlier to the stock quote stream to present the end user with a real-time update on the value of their performance in stock positions, right? So stock quotes are coming in. I know my stock positions already that we talked about. I own 100 shares or 1,000 shares of Oracle. I can calculate with that value. I can feed it in and then just say, okay, I have 1,000 shares. I can calculate the price times my number of positions and also calculate my percent gain, again in real time. And so this is equivalent to doing a left joining of a stream to a table in SQL. But logically, you can think of it as that select statement there, joining on the symbols and getting that value back. And I'll talk. And so here's the code that implements that. I'll share the code afterwards. I can't share the code right now, but it's basically focusing on, we have a new consumer in there, but on the table view on the top stock position itself, at the very top, I create my table, and then I'm listening to the stock quote stream, so I'm just doing a regular consumer on that, adding a message listener. Every time I get a new ticker symbol in there, I filter and say, do I have a position in that? Yes or no? If I don't, I'm not interested in it. I don't own those shares of that company. There's nothing to update. But if I do, then I can update it. I say, oh, that quote changed. The value, relative value of your position in that particular security changed, and I can update it in real time. So this is the joining of a table to a stream. In the stock trading platform, you provide the user with a summary page of all their different, combines their most recently quoted price along with various daily statistics. Such as the trade volume, daily high, low, some of this. So again, in this scenario, we're going to join two table views together. I presented the table views earlier. So we have a stock quote table view. Again, that's being fed by stock quotes in real time. A high volumes system, we just put a simple table on top of that to update those values. And we have our stock statistics table view, which we talked about. There's a processor in between that's executing every trade, updating daily mins, highs and lows, and trade volumes. Since they're both keyed by the same symbol, it's easy to join them as well. So this will represent joining 2 table views together, and it's equivalent of a left join on one table on another in SQL. And I'll show you how to do that here in the code. Again, I'm going very quickly, but the code is available, I promise, on GitHub, publicly available. You can look at it. Here, this is how you would do a very similar thing. You create 2 separate tables on that. And this is a one-time thing, so you have a stock quote table, you have a stock stats table, and you do a for each. This is going to be a single scan, one single time. Go through it, and I'm joining them themselves, and then I'm outputting, here's the quote, here's the high, here's the low, here's the volume, here's the time it was. These are the ones that you're interested in. This is a one-time thing. In my demo, I put that particular for each in a separate loop, so I do it every 10 seconds if I want to update that sort of thing. But it's representing just a for each. It's a single scan through the table one time, and I have to, outside of it, trigger it myself to do multiple times. And then the last and most interesting one is the continuous table view join. So after a trade is done, you want to maybe update the user's user interface, reflect their new positions. Of course, all my notifications come up. I'm late for meetings everywhere. Apologize for that. So you can join a slowly, this is good if you're joining a slowly changing table with a fast changing table. I tried doing it with 2 different really fast tables and it didn't do well. There's significant lag between the 2 of them. But if you have a stock position table, again, what positions, securities you actually own, unless you're like an algorithmic trader, those stay pretty static. You're not going to have not Oracle, 500 securities down to 2, pick ones up again like that. That's pretty static. That's your slow changing table there. And then your fast changing table is obviously your stock quote. So again, your stock position table view joined to your stock quote table view, but you can do it continuously. So again, it's like this left join, but we're going to instead constantly listen for stock quotes, and only those that are in my portfolio, I'm going to do an update on my user interface to say, hey, look, now you've lost more money or you've made more money, these types of things. There we go. Sorry about that. So let's look at the code for this as well that implements this pattern right here, and I'll be demonstrating this all in a live demo again. So again, you have the stock position table, which is your slow-moving table, and we're going to have a continuous scanner on this, right? So for each one, I calculate it once, and then I listen, and then I go through for each stock in my portfolio. I go get the stock quote table, and I do a lookup. I do a get on that one, so I'm doing a continuous join. And then again, if it's my quote, I do something with it. If it's not something I'm interested, I don't. And that implements that pattern. But this one doesn't require a secondary loop to keep doing it. It's just going to continuously update itself. As new quotes come in, I'm constantly updating my information. And with wrapping it up here, so Pulsar's TableView, it provides a database abstraction on top of topic data. So again, you have these, as long as it's a keyed data type, you can be using a compacted topic to minimize that data set for a quick scan. It provides you, your interface is a keyed table that you can do different access patterns on. You can do joins or demonstrate SQL type joins information by joining streams to table views to other table views, and doing continuous joins, all using a Pulsar client, no additional SQL infrastructure required. So very similar to what Ktables does, but it's Pulsar's very own database table abstraction. Any questions on that? I feel like I rushed quite a bit, but I was tempting the demo gods. So whoever's running the queue, be handed off for